Here we have a Wurlitzer 200 with the vibrato thumping in the background. This is caused by an overactive oscillator and can be remedied by placing a small capacitor across this trimmer right here. This capacitor is an 0047 and it can only be trimmed a little bit. It could be as 180, 200, 300, 400 picofarads, but not more. And not only that, we want you to see that lead dress and placement. Like, for example, these leads to the power transformer are not twisted on this unit when they're brought near a capacitor. The pickup to the read bar is increased, and so therefore, to quiet the Wurlitzer at its best, these two black leads need to be twisted, and not only that, they need to be foil enclosed or enclosed in some tubing. We prefer the foil, it's much easier to work with. So there you have two sources of pickup. One is through this capacitor, which goes to the 560K and the read bar itself. As you can see, it's picking up rather easily, and you can hear it in the background. And it's even worse with the vibrato on, because the vibrato increases the gain. You want to keep the wiring in this area if possible, and not draped over the board. Alright, that's one wire on the transformer. Now it's important that you twist the wires to the transformer, because that cancels some of the magnetic field. In other words, the magnetic field on one wire is the opposite from the magnetic field on the other, and when they're twisted, they tend to cancel each other. This produces a quieter output than if you just had the leads running straight past. And the second thing you should know is that you can do that twisting procedure, with, say, an auxiliary output and a ground. It has to be a grounded lead, and that you can go without actually shielding a wire or having a shielded wire for some distance before it picks up. Okay, here we have our transformer leads pulled out, and you're going to execute a twist that's approximately 2.5 turns per inch. Anything less than about 2.5 turns per inch may not be effective. Okay, we've got the wire twisted, and this is where we're going to place it, on the edge of the rail with some foil tape. We've applied the copper shielding tape around the bottom of the unit. The wires are underneath, and the lip extends over to here where it's been folded over so that it can be adhered to the chassis. This completely surrounds the 110 volt AC wiring, preventing any E field from coming through, and the twisting of the wires presents a problem for any M field or magnetic field coming through. So the end result should be a slight change in the hum quotient. Now, it doesn't matter if you reverse these transformer wires. They're both black, and they will be the same as far as which way they go in. It is important that you have them properly connected, and on some transformers, some Wurlitzer transformers have 4 input leads because they were designed for 220 volt operation. so they can be switched through. If you have one of those transformers, refer to our website for the diagram. And that gets you in as far as the AC wiring is concerned. And now, if we were to test this matter, we would find that it's much quieter. That thump is rather annoying, and that is the next item we will address. Alright, this is with regards to the vibrato thump. We're putting a small capacitor. We suggest you start at about 150 to 200 picofarads across the 0047, which is in the schematic, a cross between base and collector of transistor that is used for the vibrato oscillator. What this is going to do is soften the wave shape slightly. It's going to take it from almost a triangle shape and make it more sine, more gentle. You can hear it vibrating in the background right now, and I'm going to turn this off momentarily, and I'm going to solder the capacitor in. And now I'll let you hear it. See the reduction. Okay, we've discovered that 180 picofarads wasn't high enough. We've now gone to 470. Here's the before. You can hear it quite readily, and there's the after of the 470. Now, if you go too high, the vibrato simply stops working.